Welcome to a new video. Today we are going to talk about handling imbalanced datasets in machine learning. Before we jump into the code, let's understand what an imbalanced dataset actually is. Imagine that you are building a model to detect fraudulent transactions. Naturally, you would expect to have way fewer fraudulent cases compared to legitimate ones. This creates an imbalance, and if left untreated, your machine learning model might simply predict the majority class for every input, yielding high accuracy but poor generalization. All the techniques we are going to cover in this lecture can be applied to the real-world datasets, but I'm going to take a data creation code from ChatGPT and create a synthetic dataset for this lecture for it to be simple and easier to understand. Here is our synthetic data creation code, and let's just see X and Y here. So basically what we are going to do is, let's just quickly talk about that. We are setting the weights parameter to make 10% of the samples belong to the minority class and 90% to the majority class, creating an imbalance. You can see the weights here. So let's quickly train a basic classifier to see how it performs on this dataset. We are going to use logistic regression for that, and we are also going to use train test split and classification report. Let's just say from sklearn.model selection import train test split, from sklearn.linear model import logistic regression, and from sklearn.metrics import classification report. Let's start by splitting the data: xtrain, xtest, ytrain, and ytest is going to be equal to the train test split x, y, and let's set test size to 20% here. Let's train a logistic regression model. Classifier is going to be equal to the logistic regression, and we are going to fit this to our data: xtrain and ytrain. Let's make predictions, y predictions, classifier.predict, xtest, and evaluate the model, print classification report. Here it is. We will say ytest and y prediction. There are great scores like accuracy here is 0.98, great F1 score, great precision. It seems great, but there's a problem. Now we have a model that has high accuracy but poor recall for the minority class. That's a classic sign of imbalance affecting your model's performance. So let's get over this. Let's start by resampling techniques to handle this kind of situation. One straightforward technique to deal with imbalanced data is to resample it. We can oversample the minority class to balance out the class distribution. For this, we are going to say from imbalanced learn over sampling import random over sampler, and we are going to say random over sampler, and let's just create random state for you to get the same results if you want. And we can just say x. Actually it's nonsense because we didn't do that at the train test split, so let's just forget this. We can say x resampled, y resampled, fit resample x train and y train. Let's train a new model on this resampled data. Fit x resampled and y resampled. Make new predictions. Y pred is going to be equal to the, let's say, resampled after this, going to be equal to the classifier.predict xtest, and evaluate this model's performance this time. Classification report ytest and ypred resampled here. So you can see the increase of recall here. So this is a way, and let's get into some more advanced techniques like synthetic minority oversampling or adaptive synthetic sampling. Let's import them from imbalanced learn dot oversampling import smooth and ADSYN. Let's start by using smooth here. smooth, and we will say, let's just say like x resampled, y resampled going to be equal to the smooth. It's smooth, and we will use fit resample, x train and y train, and we are going to train the new model classifier logistic regression classifier.fit x resampled, y resampled. Here it is. Let's make new predictions. Y prediction resampled is going to be equal to the classifier.predict x test, and let's just run this, and we are going to evaluate the model's performance. Print classification report y test and y predictions resampled. So the recall stays same. Not every technique for the all datasets, so you just need to try out and find if it's performing good or not. Let's just use ADASYN. I don't know how to read that, so I just call it like that. We will say ADASYN is going to be equal to the use this class, and we will use x resampled, y resampled, ADASYN fit resample x train and y train, and let's train the new model classifier logistic regression classifier.fit x resampled, y resampled. Now we are going to make new predictions. Resampled is going to be equal to the classifier that we are going to use predict, my bad, x test here, and we are going to evaluate the new model we create just like others. Classification report from here, y test and y pred resampled. You can see recall is increased now, but this is not the only metric. We also need to check for precision, F1 score accuracy. Smooth and ADASYN both create synthetic samples of the minority class by interpolating between existing instances, but they do so in slightly different ways. You need to try all the techniques, maybe not all of them, but try some of them and find the best performing one, like this here. Either of these methods can be a good option for addressing class imbalance. That was all for this video. Thanks for watching it. You can subscribe to my channel for more data science content like this. Have a great day.